So I just want to quickly, I'd say it'll take 20 minutes, maybe 10. I haven't timed it. But then we would have gone over complex numbers. And the reason I'm doing that is because complex numbers is one of the banker questions. So if you look over the past papers, and this is for ordinary level, complex numbers gets asked nearly every year. I'd say 4 out of 5. So that means, you know, if you're going to do anything, you'd want to do complex numbers, or you'd want to be doing the bankers. They're basically the collection of questions that come up nearly every year. And since basically most topics are standalone, you know, you can just do complex numbers, even if, you know, you haven't done, say, trigonometry, or, well, I suppose trigonometry, I do mention Pythagoras, but that's, you know, just for those who know the crossover, but you don't need it. So basically, you know, you can just start by doing, because basically what I found was over the last few years, I kind of every time would come back to these bankers, you know, that I was kind of going, oh, what could I do that would be most helpful? And I'd end up doing the bankers more kind of March, April, May. So as you're coming right up to the exam, just to basically go, look, even if you haven't done anything, you can still do these bankers, and you can just, they're the most efficient way to convert work into marks. They're the safest marks. And so basically that's what someone should begin with. Anyway, I think it's about 5 now. Oh, it's gone past 5. Okay. So now I can start without feeling bad that I started before I was supposed to. And then if people came at 5, then they went, oh, what happened? I came on time. So here we go. I'll get rid of that. So firstly, I'd say do sign up. So if you just go to the Living Cert Maths Guide page, you can just click on sign up. What that means is that you're sent to an opt-in page, a page where, you know, you can just give your name and email. And that's handled by Aweber, you know, and they're one of the leading mailing list people. So it doesn't rely on anything I do, you know, so it's securely, safely kept. Everything is handled by Aweber. So why would you want that? Well, it's the basic promise of the site. So I thought, what is the most useful thing, or what are the most useful things for students? And I'd look around, I'd be in touch with what's out there, and you get sent them on the mailing list. So, otherwise I might mention them on the Facebook page. But get rid of this. But that only is on that page for that day, maybe that week. So yes, I might have put that that interesting page and told people about it 4 months ago. I don't know when you're starting. But if you come later, you wouldn't see that page. You wouldn't hear about, oh, there's this great resource here. And I don't want to be every week saying the same thing again and again. So that's why on that mailing list, once you just go name, email, primarily I just want the email, because then you can be emailed the messages or the lessons. And that way I can know that I've sent you them all. Also, one of the main problems with e-learning and this kind of information is that it can be overwhelming. So if I just go, oh, here's 50 fantastic pages, it's just too much. So by having an email, it can be paced. So it's automated. It just goes, when you sign on, you are sent, here's this great site. And there's lots there. You can look around. But then next week, another lesson is sent. Next week, another lesson. So that way, you're given sufficient space between the lessons to avoid the overwhelming. So that was the first thing I wanted to get out of the way. Also, there's obviously this fan page. So we're contactable there. You can just ask questions, you can comment below the video, you can send messages. I mean, that's Facebook. So enough of that. Next, because I want to do complex numbers. So the URL is here. I'll have the link below the video. The username is complex. The password is numbers 2014. So with that, you can log on. So the lessons for complex numbers are already there. And, these were given out a couple of weeks ago. So hopefully, you've followed these lessons, you've done the problems, and then you've seen the solutions. I'll slot in the problems and solutions into the mailing list, so that if somebody say were to join in a couple of weeks later, they'll be sent the problem and then the solutions and all that. So here's the system. You log on and you can just access the lessons. So I broke it into 2 bits. That's why I had problem set 1 and 2. The first was just the basics. This is a complex number. Here's how you manipulate them. So how do you add them, multiply them, subtract them? Division is slightly trickier. And so it has a separate lesson. So I'll do a quick review of these after I've gone through the system. But basically, you want to log in, do these 2 maybe together, and do the first problem set and solution. But that establishes what this is what a complex number is, and here's how you work with them. The next bit is using Argan diagrams. And that's just representing the numbers graphically. So an Argan diagram, well, I'll go into that later, but you have an axis for the real component and one for the imaginary. So it's just like plotting on a coordinate diagram with x's and y's, except here one of the axes is for the imaginary number. So you'd want to have done this bit so that you know what complex numbers are, you know how to manipulate them before you start doing this bit. Though it's very automatic and routine. We'll also look at the modulus and how complex numbers appear when it comes to quadratic equations. So that's all we're going to do. And the idea is once you've done all of this, and it doesn't take long. I mean, if you give yourself maybe half an hour or an hour to do the first bit and the second bit, then you should be okay. But once you've done this, you've now done complex numbers. And then what we have is the model solutions. So you can now go to see the question on complex numbers in 2012 and in 2013. There's no real point doing more than that because each problem is going to be different. I mean, if you can, the idea is that you more to kind of build confidence and show yourself, to show you that actually, look, you are ready. You would be able to do the exam. So that's the first two things I wanted to look at. You want to log on to here and go through the lessons, and just the idea of signing up to the mailing list so that you get, for example, where some of the best maths lessons which are available in the world, which is free. So that kind of stuff. So okay, then I just wanted to point out how this kind of system fits into what you're doing. So one way is to just go, I'll just do the banker questions. So I'll just learn complex numbers. I'll look at sequence and series. I look at volumes and areas. So, I mean, they're all bankers, and you can just begin by doing them. Since, again, most topics are standalone. So you can just do that. It doesn't matter what background, what other topics you've already done. The other way is to just look at the lessons on what you're doing in class, in school. So, you can kind of look at the videos, get the basic ideas, and get a heads up before you begin the material in class. And then that way, when you do it in class, you'll be a genius because you're already quite familiar with it. Now, when you're actually doing your homework, you're doing your problem sets, you've already seen how to do it, you've been shown how to do it, you're doing it the second time. So, yeah, you'll be ahead. To point out or mention So, if you just go to complex numbers on Wikipedia, it's very similar. It's Argan Diagrams, imaginary real number. So, what you're doing is complex numbers and what people talk about. The thing I wanted to mention here was the history. So supposedly complex numbers first arose in the 16th century in Italy. But that's not what I wanted to mention. I just wanted to point out blah, 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 blah. And then, which last time I saw it, I must have seen another page. Let's do a search. So, history in brief. Many mathematicians contributed to the full development of complex numbers. The rules of addition, subtraction, multiplication, and division. That's what we're just going to do after looking at this Wikipedia page. Were developed by Italian mathematician Bombelli. Actually, didn't know that. A more abstract formalism for the complex numbers was further developed by the Irish mathematician William Rowan Hamilton. So you might have heard about him, but he was Irish mathematician based in Dublin. So now on to just going through complex numbers. Screen share. Yeah. Okay. I don't want that. And I'll turn chat on again there. So I want to do complex numbers. So 2 bits. And that's how the lessons were done. So this is on complex numbers. The magic is I. I is equal to the square root of -1. That's a strange new object. So what that means is that I squared is equal to -1. Now, if you think about it, if I have -1 multiplied by -1, that gives me +1. If I have +1 multiplied by +1, that's equal to +1. So if I is positive or negative, I squared is positive. So whatever I is, it's not a number. I mean, it's not a real number. Because as I said, if I was positive or negative, then I squared would be positive. So I cannot, this is pretty poor. Cannot be a real number, since if positive or negative, it would be positive when squared. So it's in the same way, though, that before people had fractions, you couldn't, there wasn't a way to describe if I cut my pizza into three pieces, how much does each person, equal pieces, how much does each person get? Now I can just say if it was three people, each person would get 1/3. But that's only because we've invented fractions. And that took a long time. So likewise, complex numbers extends what we can do. Also, they used to have the absurd equation. So you'd have x plus 1 is equal to 0, find x. And people would laugh and say, that's absurd, because they didn't have negative numbers. So once they developed that, then this was an easy question. So complex numbers are like that. It's you are generalizing, broadening what a number can be. The way complex numbers are written is with two components. So a complex number, I'll just say Z, is, say for example, 1 plus 2i. So you have a real part, that's your normal number, which you're familiar with working with. And then you add a complex component. So that's plus 2i, where you know that I squared is equal to minus 1. So that's a complex number. Then we have to, then we need to know how to manipulate this. How do we work with complex numbers? Well, first we see adding. And these are done in the lessons if you log on to that, complex numbers 2014. So if you have, say, 1 plus 2i, and you add 1 minus I, we treat the complex and the imaginary parts separately. So we first add the complex real parts. So 1 plus 1 gives us 2. 2i minus I gives me I. And that's it, because we're just adding them. Subtraction, same thing. So say I was 1 plus 2i minus 1 minus I. Well, we subtract the real component. So 1 minus 1 is 0. And then we subtract the imaginary component. So 2i minus minus I. So minus minus is plus. So that gives us plus 3i, which we'd write normally as just 3i. We don't need to write 0. Multiplication, no surprises, just as you'd expect. So we have 1 plus 2i multiplied by 1 minus I. Well, we first multiply 1 plus 2i by 1, like that 1 there. So we get 1 plus 2i. Then we multiply 1 plus 2i by minus I. So that's minus I multiplied by 1 plus 2i. So we just keep working through that. So that's 1 plus 2i minus I minus 2i squared. That's 1 plus 2i minus I squared is minus 1. So that's plus 2. So that finally gives us 3 plus I. We're nearly done with the first block of complex numbers. We just have division to do. I'll try and actually be messy and cram that all into this page. So I'll do 1 plus 2i divided by 1 minus I. Here, we use our trick. We multiply by 1 plus I over 1 plus I. So that's equal to 1. So we're just multiplying something by 1. We're not changing anything. The reason we're multiplying by 1 plus I is because if you multiply a complex number by its complex conjugate, you end up with a real number. So the complex conjugate is just the number with the sign in front of the imaginary, in front of the I changed. That's why 1 minus I becomes 1 plus I. The complex conjugate of 1 plus 2i is 1 minus 2i. So if you just multiply these out, well, I've done... No, I haven't. Sorry. I thought I'd multiplied these two already. Now I multiplied by its conjugate. So the top will be 1 plus 2i plus I minus 2. Okay. The bottom will be 1 plus 1. Because I'll have 1 plus I, and the minus I will give me a minus I. I'll have minus I squared. I get plus 1, yeah. Then I just group those together. I have minus 1 plus 3i over 2. So I should write. And that's how you divide by any complex number. You just multiply by its complex conjugate over its complex conjugate, and then work it out. So that's the first block of stuff associated with complex numbers. And again, you know, in the lessons and in the problem set, I broke it into two pieces. You know, so we would do just this lot of how do I add, subtract, multiply, divide. And once you're happy with that, once you've done problems on that, then you're ready kind of for the second section. Because you don't want to be trying to do too much at the same time. So give yourself a little bit of time to practice, to kind of go, what are you unhappy with? What doesn't make sense? And then ask questions about it. You can comment underneath the videos. You can comment on the Facebook page. So just sort that out. And then once you've done the next block, you actually have done a banker. And now you can try the past paper because you should be able to do them. So I'll blank this page. New. Don't save. Boom. Next. And remember, with video lessons, you can always pause. You can come back to the second part later, that kind of stuff. So it's not just because it's a 30-minute video doesn't mean you have to sit there for 30 minutes. So Argan diagram. That just means you have your real axis and your imaginary one. So say I'm trying to do 2 plus I. This would be 2 plus I. And we also did, if you just look at the solution to problem set 2, we basically just go through this process. So we look at representing a number on an Argand diagram. Then we multiply a number on an Argand diagram by I and show that it does rotate it by 90 degrees. So it'll flip from the top right to the top left, from the top left to the bottom left, from the bottom left to the bottom right. And if you multiply it 4 times, you get back where you started. Because remember, I squared is -1, so I to the power of 4 is 1. We also mentioned the modulus. That's actually just the distance from the origin. Oh. So if z is 2 plus I, the modulus of z is the distance from the origin to z. So, and that's where, I mean, you can just use the formula anyway, but that's just Pythagoras. So the modulus of z is equal to 2 squared plus 1 squared, square root. So you just take the real number, square that, and add the complex coefficient. So you forget about the I, you just write 1, square that, and then take the square root. So that's the square root of 5. As an aside, if you get z bar, that's the complex conjugate. So that'd be 2 minus I. Then the modulus is equal to z multiplied by z bar square root. So remember, if I do z is 2 plus I, z bar is 2 minus I. If I multiply them, I end up with 5. So the modulus of z is equal to the square root of z by z bar. Finally, we have quadratic equations. Again, that's done in the solutions to problem set 2. The point or the issue is if say you have a quadratic equation, normally it'd be like something like that. And it will cross the x-axis at 2 points. And there are your 2 solutions. But you can have quadratic equations where it's like that. When you plot it for different x's, the function actually never reaches the x-axis. For those equations, the solutions are complex. You'll end up with something like 2 plus I, that. I mean, that equation does have a solution. I mean, where it solves the algebraic equation. So, say you have, I think the example I had was x plus 2x plus 10, or I forget what the specific equation was, but the solution was maybe 3 plus I and 3 minus I, or whatever. So using the formula, you get a complex solution. So graphically, you look at it and go, there is no solution. I mean, because it doesn't actually cross the real number. But remember, the formula you basically have b squared minus 4ac is negative. And if it's negative, you end up with a complex number. So that's how complex numbers appear when it comes to solving quadratic equation. So that's all we need to know about complex numbers. Do go over the lessons. Do break them into manageable pieces. So, don't try and do, I'll do all of complex numbers in half an hour or something. Just watch all the videos straight after each other. Watch the first one, maybe the second one. Give yourself some time to kind of think about it and kind of go, does this make sense? Why doesn't it make sense? Because it's a totally new idea. So give yourself some time to think about it, play around with it and go, okay, what's wrong with this? Why do I think this doesn't make sense? Can you write that down? Maybe just ask a question under the videos or on the Facebook page, and slowly sort it out. So that's, as I said, complex numbers, which are a banker. So it comes up pretty much every year. You want to get that sorted, and then you don't have to think about it. So that way things are under control. We're going to do sequence and series next. Remember to sign on to the mailing list, because that way you'll get, the best maths lessons sites. Well, I won't tell you all of them now, but the best strategy, because people have been doing exams for ages. People have the same problems. So there's advice for that. Till next time.